Hello, my wonderful, beautiful friends. Welcome back. We are on the last lesson in Unit 4 that we're going to look at for this unit, and it's all about inverse trig functions. So now we've looked at all 6 of our trig functions. Now we're going to look at the inverse of these functions. So only 2 objectives today. We're going to evaluate the inverse trig functions. And this is kind of silly. It doesn't really make sense, right? So evaluate inverse sine. Let's look at sine. Let's look at sine. Inverse sine functions. And then we're going to look at the inverse of other trig functions. So not just sine, but we're gonna start with sine, okay? And we're gonna say, okay, how do I find the inverse? So basically how I like to think of the inverse of these is it's just saying, if I asked you to find, right, sine of pi over 6, let's just say, right, you would tell me, okay, that is 1/2. The inverse function is just going the opposite way. So we denote it with this -1 or with arc sine. Sometimes you'll see arc sine. And this is just saying it'll have this, right? And this is just saying what angle has a sine value of 1/2, positive 1/2. Okay, so you're just kind of thinking about it opposite, saying what angle gives me a sine value of 1/2? And that angle is pi over 6. So just kind of going the opposite way. There's a couple things that we need to point out here in the definition. There's a restricted domain on this, okay? It has to be between negative pi over 2 and positive pi over 2. If we think of the range of sine, so let's think of the sine graph real quick, right? It's going to be real bad, but it's doing this, more or less. And the range of this is -1 to 1, right? So it comes up here to 1, and it comes down here to -1. So when we're talking about the inverse of this, that means I'm restricted, and I can only look at values that give me -1 and 1. Okay, so down here is the point 0, -1. So that gives me the y value of -1. And up here is the value 0 to 1, which gives me that y value of 1. So this is how we get to the restricted domain. Okay, so if I go this way, I get to pi over 2. And if I go this way, I get -pi over 2. So my answers can only be in quadrant 1 or quadrant 4. Okay, so answers only allowed in quadrant 1 or quadrant 4. Okay, so that is where I'm restricted. I'm restricted to quadrant 1 or quadrant 4. But really all it is just thinking, okay, what angle gives me this y value, this output of sine? So let's look at a couple examples, and hopefully it's not as bad as it sounds. So we'll do 3 together, and then you guys will try 3. Okay, so it says, if possible, find the exact value. Well, I know I'm working with sine, so I'm only going to draw quadrants 1 and 4. Okay, now I want so this tells me sine is -1/2. If sine is negative, that means the angle is going down, right? It's going down somehow. And that tells me that this y value is -1/2. Okay, so we can use our unit circle or whatever we need to do. But if I know that this is 1/2, hopefully we are masters at the unit circle now enough to know that this is √3 over 2, which tells me that this angle right here going in the negative direction is -pi over 6, right? Because positive pi over 6 is right here, where this is 1/2 and this is √3 over 2, and that's pi over 6. So if it's going down the negative direction, it would just be negative pi over 6. Okay, so the arc sine of negative 1/2 is negative pi over 6. That is the angle that gives you negative 1/2. Okay, let's look here on B. Again, different notation, but it means the same thing. So here I want the sine inverse of root 3 over 2. It's positive, so that tells me it's going to go up. So I'm just going to draw a random angle. And that tells me that the y-coordinate is root 3 over 2. Okay, which hopefully, again, we know the unit circle well enough. That would mean this is 1/2. And so this angle right here is pi over 3. And that's it. Okay, then the last one. Okay, I'm looking for when is my output 2. So here, right, it's 1, 0. Here it's 0, 1. When do I get to 2 on my output? And hopefully the answer is never, right? Because the highest I go is 1, and then it starts going back down from 1. So this is not possible. So this is not possible. And we can say sine cannot equal 2. There's no angle that is going to give me a sine value of 2. Okay, so we have 3 u tries here. Be very, very careful in F. Notice it's cosecant, so you have to take the reciprocal. But go ahead and hit pause on the video and then give these guys a shot. All right, so hopefully we tried these. So let's look at question D here. And it says sine inverse is negative root 2 over 2. Since it's negative, I know sine, right, goes down. So it's going to be down here. And I know that this distance right here is negative root 2 over 2, which again, knowing the unit circle tells me that my x distance is positive root 2 over 2. And what is that angle? That angle in the negative direction is negative pi over 4. I don't know why I didn't box this one. My apologies. There we go. Okay. For E, let's see. Sine value of 0 right here is the point 1, 0. So I have a sine value of 0. What is the angle that gives me that point? And that angle is 0 radians. We're not using 2 pi because I have not gone all the way around. Okay. My answers have to be somewhere between pi over 2 and negative pi over 2. So I can't use 2 pi. Just like here, I wouldn't be able to use 7 pi over 4. My answer has to be between negative pi over 2 on the bottom and positive pi over 2 on the top. And then the last one is cosecant inverse of 2, which remember is the same thing as sine inverse of the reciprocal of that, which is 1 over 2. Okay, so when I go to graph this, I want my sine value to be 1/2. I'm going to draw my angle. That tells me that this value right here, I want to be positive 1/2. Again, knowing the unit circle, this is root 3 over 2. So that tells me that that angle is pi over 6. And that's it. So it's just kind of thinking about it in the reverse way, but it does require that we know the unit circle fairly well. So if we're still struggling with the unit circle and we want more practice or whatever, just make sure that you reach out for help. Let's look at how do we graph the inverse. Okay, so let's clear this. Okay, now we're looking at how do I graph the inverse of sine by hand. Okay, so I am going to kind of draw this, okay? At negative pi over 2 right here, the point is 0, negative 1. So what is my sine value? Negative 1, okay? At negative pi over 4, This is, root 2 over 2, root 2 over 2 negative. So my sine value here is negative root 2 over 2. At negative pi over 6, my sine value here is negative 1/2. Okay, and then at 0, right, so 0 radians right here, my coordinate is 1, 0, so the sine is 0. And then if I go the other direction, it's just going to be the same thing, just positive. And so what happens is when I graph this, I'm going to try really hard to make this graph pretty. It's just the inverse of a sine graph. So I'm going to skip 1 and call this 1, and then skip 1 and call this negative 1. Okay, and then I'm going to go 4 tick marks. So from start to finish, right, from negative 1 to 1, I go from positive pi over 2, and then I go to negative pi over 2. So again, just following along what my y's go from negative pi over 2 to positive pi over 2. And so this is a little confusing. Notice the x's are on the bottom and the y's are on the top. So it's kind of reversed here. So let's then go ahead and graph this, okay? I know 0, 0 is a point. Here at positive 1/2, I have pi over 6, which is here-ish, right? Because this is pi over 2, so this is pi over 4. At root 2 over 2, which is 0.7-ish, I have a point at pi over 4, which is here. And then at pi over 2, I have 1. And then I'm going to repeat. So at negative 1/2, it's pi over 6, which is here-ish. So, excuse me, negative pi over 6, right? At negative 0.7-ish is negative pi over 4. And then at negative 1 is negative pi over 2. So when I go to connect this, oh boy, what we actually see is half of a sine wave, right? So then it just continues here. I guess it's more than half. Oops, that's not what it looks like at all. It's more than half of the sine wave, but it's the sine wave nonetheless. Okay, so it's just the sine graph. And remember the inverse, you just flip the x and y coordinates. So that's all we did, right? So instead of at 1, 0, or I guess we're at sine, right? So instead of at pi over 2, instead of at pi over 2, 1, it's at 1 pi over 2. Instead of at pi 0, it's at 0 pi. So you just flip those x coordinates. So it's just the reciprocal, the inverse of the graph. You just flip the x and y values. So hopefully that makes sense. Again, the graph is a little weird, but hopefully at least solving them makes a lot of sense. So what we're going to do now is we're going to look at the inverse of cosine and the inverse of tangent, which very, very similar ideas, right? I give you the coordinate and you tell me the angle, okay? So again, the notation is the same, either the negative 1 up on the cosine as a subscript, as a Sanskrit, what's the top one? I don't know. Or we can say arc cosine, okay? So arc cosine as well. Okay, now the only difference is cosine has a range from 0 to pi. And again, if we think about this with the unit circle, it ends up making sense that cosine, inverse cosine, is only going to be coordinates 1 and coordinates 2. So answers in quadrant 1 and quadrant 2. Okay, so that gives you the full range of cosine. Over here, I would have positive cosine values, and over here, I would have negative cosine values, remembering that cosine are my x-coordinates. Okay. Tangent, very, very similar, right? Denoted by the little -1 or arctan, either way. This is a typo. This should be tangent. And then again, tangent is the same as sine. Okay, so tangent is gonna be quadrants 1 and quadrants 4. Again, we're going from -π/2 to +π/2. Up here we have positive tangents, and down here we have negative tangents. So here my answers are in quadrant 1 and quadrant 4. Okay, so your answer's right, so yeah, that's it. Okay, so let's look at some examples, and hopefully we realize it's pretty much exactly the same as sine, just cosine and tangent. Okay, so arc cosine, so since it's cosine, I know it's going to be quadrants 1 and quadrant 2, of positive √2/2. Since it's positive, I know it's going to be doing this, right? Because this is √2/2. Well, if that's √2/2, this is also √2/2. And so hopefully we know that the angle there is π/4. Again, I'm telling you the coordinate, you tell me the angle. For B, same thing. I have cosine inverse of -1. So I want my output of -1. So that is right here, right? Because this is the point -1, 0. So what is the angle of that? The angle of that is π. So I want you to, before we go on to tangent, I want you to try E, F, G, and H. I know that H doesn't fit on here. Sorry, we'll still go over it, but I want you to do E, F, G, and H and try it and see how it goes. And then I wonder if I can get, can't really see H still, so sorry. But do E, F, G, and H, pause the video, try them, and then when you're ready to go over it, hit play and we'll go over it. All right, so let's review these before we go over our tangents. Here I have cosine, and it's -1/2, right? So I want my x value to be -1/2. That tells me that my y value is going to be √3/2, which again, if we know the unit circle, hopefully, cross our fingers, that leads us to 2π/3. So that is my angle. For f, I want cosine of 1, that is right here, 1, 0. Cosine is 1. And again, remember, my answers can only be between 0 and π. So I'm not writing 2π as an answer here. I'm writing 0 as an answer. That is 0 radians. For g, my cosine is negative. So over here, this is -√3/2, which leads us to know that this is +1/2. So the coordinate, or the angle that matches those coordinates, is 5π/6. So this really just comes down to knowing the unit circle really, really well. For h, okay, it's a little bit tricky because it's secant, not cosine. So remember that it's going to be the same thing as cosine and then the reciprocal. So that leaves 3/2√3. So that's the reciprocal. I cannot have 3/2√3 because there's a root on the bottom. So to get rid of that, I have to multiply by √3/√3. Right? So that leaves me is 3√3/2 times 3. My 3's can just cancel. and I get root 3 over 2. So this is really cosine inverse of root 3 over 2. So now I can go ahead, right, and I can draw them. If it helps you to draw it, it helps me to draw it personally. It's positive 3 over 2, root 3 over 2. So this is root 3 over 2, which means this guy is 1/2. What angle fits that? And we should know that it's pi over 6. So that's our practice of cosine. Very, very similar to sine. The only difference is I'm looking at the x-coordinate instead of the y-coordinate. Okay, let's go back up then. Let's look at our tangents. Okay, for tangent, we're looking in quadrants 1 and 4, right? Remember that tangent is y divided by x, okay? So if my y divided by x is 0, that means I have a 0 on the top and a 1 on the bottom. So that is this point right here, 1, 0, right? 0 divided by 1. What angle is that? And that is 0 radians. Again, your answers have to be between negative pi over 2 and positive pi over 2. For D, it's a negative, so I know it's going to be down here in quadrant 4, and it's 1. So that means that I'm going to divide something by itself. So that leads me here to root 2 over 2, comma, negative root 2 over 2. If I divide those things, I get negative 1. So what angle is this? This angle is negative pi over 4. So same idea, just a little bit harder because we have to know our tangents as well, okay? So go ahead and try I and J. J is a cotangent, but you'll just take the reciprocal and it'll be the same thing. Okay, so try I and J and see if we can figure out what those tangents are. Okay, so let's kind of look at our tangents. Hopefully by now, we kind of have an idea of all of the different tangents, at least in quadrant 1. Okay, so here at pi over 6, the tangent is root 3 over 3. At pi over 4, the tangent is 1. Let me write that a little bit further away. Tangent is 1. At pi over 3, the tangent is root 3. At pi over 2, it's undefined. And at 0, it's 0. So knowing these tangents, okay, and maybe you had to calculate them by dividing your y over x or whatever, but that's kind of how we figure out the tangents here. So when it's something other than just 1. Here the tangent is negative, so I know it's going to be down here. And I really just look and say, okay, which tangent is root 3 over 3 in the positive, and it's pi over 6. So down this way, and it's just going to be negative pi over 6. So the tangents in quadrant 1 are positive, and the tangents in quadrant 4 are negative. And then the last one is cotangent inverse of 1, which means we have to do the tangent inverse of the reciprocal. Well, the reciprocal of 1 is just 1. Okay, so tangent of 1, it's positive, so it's going to be up here. And just hopefully now we know the tangent of tangent of pi over 4 is 1. So tangents are a little bit more tricky just because you have to do like a little bit of extra work to find the tangents. Or again, if we can just know the tangents in quadrant 1, then we should be set with finding the tangents in quadrant 4 as well. The last thing we're going to do before we kind of move on to some application and review is just looking at how do we do this in our graphing calculator, okay? So it says use a calculator to find the approximate value if possible. This is tangent, sorry. Arctan, remember, is the same thing as the tangent inverse, negative 8.45. So those two things are the same thing. So depending on how it's written, it doesn't matter. Either way, there's a button on your calculator And it's that second tangent, right? Second tangent. Got you right here. So right above tangent is tangent inverse. Okay, the only thing, we have to continue to make sure that we are in radians and not degrees. If you are in degrees, you will get the wrong answer because all of these numbers are given to us in radians. Okay, so I'm just going to do second tangent, which gives me the tangent inverse, and then the negative 8.45. I'll enter it into my calculator nice and easy, and I should get negative 1.453-ish. And I use approximate because I am rounding. Okay, so I want you to try to find these other two using your graphing calculator, and then go ahead and hit play, and we'll check our work here in a second. Okay, so for B, you should have gotten about 0.247, so make sure that you're getting that right in your calculator. For C, this is what you're entering into your calculator, and you probably got something that says the domain error, right? Domain error. So ask yourself, what angle gives me a cosine value of 2? Well, the highest cosine values I get are 1 and right, it goes from negative 1 to 1, right? I can never get to 2. So domain error makes sense. It's your calculator saying, hey, there is no angle that gives you a cosine of 2 radians. So this is not possible. Right? Just like we did with sine earlier on that sine of 2, sine inverse of 2, that was not possible. It's going to be the same thing. Okay, so now we're going to look at our application exercises, and then we have 2 mixed review problems. All right, so let's look at our application exercise. So in video 246, we did the problem at the end where the plane was flying away from the house, and we were able to find the equation of the plane, right? So here's the house. I'm going to draw it really, really poorly, but that's okay. Here's the plane. And then we did this, right? And it had an angle of elevation, which was theta. This was 2. And then this was D. Okay. And it wanted us to write, as a function of, or as a function of D, or D. They wanted me to write, wow, D as a function with trig. So the equation that we got was that D was equal to 2 cotangent of X. So you can go back and look at the problem in 4.6 if you don't remember that, but this is the equation that we got. Now it wants me to write theta as a function of T, so of D. Theta and X are the same thing. I just used X in 4.6. I guess I didn't, right? Because this is theta. So let's just do it theta. There you go. Okay. So now basically all it wants is theta by itself. Okay, so instead of the D being by itself, it wants theta by itself. So I can start by dividing by 2. Right, so I get D over 2 is equal to cotangent of theta. And then I want the theta by itself. I cannot divide by cotangent. We have to think back to geometry. Can't divide by cotangent. The only thing I can do is take the cotangent inverse of both sides. What that does is it cancels, and it gives me the cotangent inverse of D over 2 is equal to theta. So now I have solved the equation for theta. So if I know the angle, right, or if I know the distance, right, then I can find the angle is what it's saying. So just taking that equation and just rewriting it so that the theta is by itself instead of the D. Okay, last 2 here are mixed review. I want you guys to try these on your own. Again, we don't need this. So again, you're going to hit pause on the video. You're going to try graphing these and quit. You might have to go back and look at previous units. These are both from last semester and previous units. So you might have to go back and look at your notes from previous units. But I want you to try it and see how much you remember. and then we'll go over both of them individually. Okay, so let's look at the first one. Here I have a rational function and I want to graph it. So the first thing I need to do is factor. So the top is not factorable, but the bottom is a perfect square, so it factors to x plus 1, x minus 1. So now I need to go through and figure out all of these different things. I'm going to start with vertical asymptote. Okay, vertical asymptotes are zeros of the bottom, but not of the top. So this tells me that x equals, I have a vertical asymptote at -1, and I have a vertical asymptote at 1. And I would highly suggest maybe doing this on graph paper. I'm going to give it a shot, but no promises on the quality of my graphing here, okay? So that tells me I have a vertical asymptote at -1, and I have a vertical asymptote at +1. Okay, next thing is there a hole? Remember, holes occur when something has a 0 above the top and the bottom. So in this case, there is no hole. Okay, I'm just trying to remember off the top of my head. So horizontal asymptote is this equation top heavy, bottom heavy, or balanced. In this case, the equation is, bottom heavy. So since it's bottom heavy, I have an asymptote at the equation y equals 0, which is the horizontal axis. What else do I need? X-intercepts, things that are zeros of the top only. In this case, 0 is a 0 of the top, so I have an x-intercept at 0, 0. And then my y-intercept is if I plug in 0 for x, I get 0 over -1, which is 0. So I have a y-intercept also at 0. So the unfortunate part about this is I only know 1 point, right? I don't know what's going on to the left of this asymptote, to the right of this asymptote, to the right of, or to the left of this asymptote, or to the right of this asymptote. So I'm gonna have to plug in multiple numbers here, okay? So I'm gonna plug in, let's do -2, since that's a pretty easy number out here. If I plug in -2, I get -2 on top, and then -2 squared is 4, so 4 minus 1. So I get -2 over 3, which, let's just say is, right, -2/3, which is down here. So that's enough to let me know that my graph is approaching my asymptotes below the x-axis there. Now I need to figure out what's going on between this asymptote and this x-intercept. So this is -1, this is 0, so let's plug in maybe like -0.5 and see what's going on. That gives me -0.5 on top, and then -0.5 squared is 0.25 minus 1. So I get -0.5 over -0.75. And let's just do this real quick. -0.5 divided by -0.75 is 0.67-ish. Positive, because it's negative over negative. So at -0.5, I'm at like 0.67, which is there. So I know that this part is going up, like so. Now I need to plug in positive 0.5 to know what's going on here. That gives me 0.5. 0.5 squared is 0.25 minus 1. And I get 0.5 over -0.75, which is going to get me -0.67. So that is down here. That kind of gives me a good idea of what's going on there in the middle. And then the last thing, I need to know what's going on to the right. So I'm going to plug in 2. If I plug in 2, I get 2 on top. And 2 squared is 4, so 4 minus 1 on bottom, and I get positive 2/3. So at 2, I get positive 2/3. So that's enough to tell me that the graph is approaching my asymptotes above the x-axis. And there's my graph. Right? So a lot of things to remember. I think this was unit 3. No, it was unit 2B. Lots of stuff to remember from back then about how to graph rational functions. Okay, let's look at graphing polynomials in part B. A little bit easier, so that's exciting. And lucky for us, this is already factored, so that's even better. Okay, so the first thing I want to look at is that I see that this has a degree of 3, and it's positive, right? Because the number, there's no negative in front of the parentheses. So that tells me that my n's are doing this. Okay. Then I can look, what are my zeros? Here I have a 0 of 1, and the multiplicity is 1 because the exponent on this is a 1. So it just cuts through. And here I have a 0 of -2, which is a multiplicity of 2 because of this squared. And so that tells me it bounces. So that tells me that here at -2 and here at 1, the graph comes up and it bounces at -2, and then it cuts through at 1. And so there's my graph. So that one doesn't have to be perfect. It's just a sketch, but using the information that we're given here. Okay, guys, that is it for 4-7. If you have any questions, if you need any help, make sure you reach out. Make sure you advocate for yourself. Other than that, I will see you guys soon, and have a wonderful day.